So today we are going to see something about the flat panel displays. Now we have to understand that these are different from the CRTs. How are they different? Because they have reduced volume, weight and power requirements. That means they will require less power and cathode ray we are using more power. Along with that, you have to understand that these panels that we are trying to manufacture, they are of reduced width. They are thinner than the CRT monitors that we were having. Now because of this, these few things like reduced power consumption and reduced weight, the thinner possibility, we are able to use these flat panel displays in several other applications. Like now we can have portable computers, we call it laptop computers. We can have several other places where we can use such kind of devices. It may be a small TV monitors or calculators, video game displays, certain mobiles nowadays you are having, tablets where you can use them, several other kind of applications where such kind of portable monitors, small size or low power requirement is there. We can use such kind of flat panel devices. Now there are certain categories of these flat panel devices. They can be emissive displays or non-emissive displays. We have to understand that emissive displays are such devices which convert electrical energy into light. So wherever we have emissive displays, we will need this electrical energy, we will use the electrical energy, and maybe definitely there will be conductors, and we will apply some of the techniques to display the lights. Okay, so we will convert this electrical energy into light, and which will be visible to the viewers. Such example of such flat panel displays are plasma panels, maybe thin film electroluminescent displays, and light emitting diodes. Other category can be non-emissive displays, where actually you don't use you don't convert electrical energy into light. What we do is we may use sunlight or any other kind of light coming from the source. Maybe we have generated the light from somewhere, and this light can be, we can use to turn this light or twist this light to generate some certain kind of patterns to display. Okay, so such things are there. It is not that we don't need electricity, we will always need electricity, but in the earlier case, in emissive displays, we are using the electrical energy to convert into light, but here we are generating light, we are using the available light, and we are just twisting it to make it available on certain pixels to display and certain patterns to draw. Okay, so let us start with this plasma panels. So plasma panels are basically, we also call it as gas discharge displays. Here you can see there are two glass plates on this side also and the other side also. Here it is green, here on this side also it can be green, but just to show you the inner conductor, it has not been green. So these are two glass plates. Let me tell you, these images are all taken from this computer graphics C version book from Harlan Baker. So you can find these images there also. So what I was telling is the two glass plates are there, and then these two conductors are there. The conductors, you can see, one is on one glass plate it is horizontally placed, and another glass plate it is vertically placed. In between these two there are gas. Okay, these mixture of gases usually include neon. Now what happens, we fire our electrical voltage on this conductors. Now the combination of these two conductors, you can understand, it will form one pixel, right, where they are intersecting. That is the position of one pixel. So these two conductors where they are intersecting, they will this particular gas in between will start glowing. They will break down into glowing plasma of electrons and ions, and it will be visible through the glass panel, and it will generate this particular light, right? Definitely there can be certain limitation, like maybe it may not be initially, actually it was not good for color displays, but later on we have tried to make it color displays and grayscale, such kind of thing. These are also possible, no problem, but not as good as it was in CRT. But now some other displays are also better than this, but still plasma displays are also a kind of display. Now it has also improved much. Now we should see thin film electroluminescent displays, where it is mostly similar to plasma display, only you can see the gas is no more available here. Now we have a kind of phosphor. This phosphor will include zinc sulfide dope with manganese. Now what happens here, you can understand the same thing. Conductors are there, the intersection of these two conductors will specify a pixel. Now a particular position, what will happen if you are applying this electricity, this electrical energy will be absorbed by the manganese atoms here on the intersection, and these atoms will actually start glowing. They will form the light here, which will be visible through the glass plates, and in a way it will be visible to the users or viewers. So this is the story of this thing, thin film electroluminescent displays. Now, if at all we have to talk something about power consumptions, then we can say that here these displays, electroluminescent displays, require more power than plasma panels. But it is the thing that here we can achieve better color or grayscale displays. No, actually in plasma it was better, I should say. Here in thin film electroluminescent, it will be little harder to display, because there was the gases which can be converted to plasma atoms. Here it is this thing phosphor, right? So it will be similar as it was in CRTs. So okay, light emitting diodes. This is also an emissive device where you will have a matrix of diodes. This matrix of diodes which will be arranged to form the pixels, and you understand there will be a refresh buffer where the patterns of the picture will be stored, and accordingly we scan line by line, and the patterns of that refresh buffer are reflected to the these diodes in terms of voltage capacities, voltage levels, that because of this voltage levels which are applied to these diodes, and a light pattern is displayed. So this is the story of light emitting diodes. If at all we have to understand more about non-emissive displays, A very important example is LCDs. Here in LCD we have to understand that we are using liquid crystal. Okay, here you can see they are pneumatic liquid crystals. Now these liquid crystals, if they are in on state, usually they are in on state, so they are in a particular way. Okay, they are arranged in this way, no problem. Few more things here you have to understand is you have two glass plates. Along with that, on the glass plate, on one side these vertical polarizers are there, on the other side they are horizontal polarizers. Okay, so whenever light is coming, they can go through this particular through one of the polarizers only. Okay, now there are two transparent conductors are there. Now these conductors, you understand the job of the conductors. These conductors, wherever the intersection of these conductors are there, it will mean a particular pixel. Right? So at that particular position of pixel, these liquid crystals are there, which are showing the path for the light. See, the light is coming through here, through vertical polarizer. It should go vertically, but these crystals make it twisted. So the light twists here and goes through here and comes out of the horizontal polarizers, and it is available for the viewers. Right? If you want to set a particular pixel to off state, definitely here you will apply certain kind of voltage to these liquid crystals, and they will all become, I should say, they will align all together, and they are not twisted anymore, and because of that the light is not twisted anymore. So these kind of devices are possible. This is liquid crystal display. Definitely in this thing that we are talking about, here also refresh buffers are there, which are went through, and pixel by pixel these are repeated. I should say, if here you can achieve 60 frames per second. These are all kind of things. Now this was the story of your LCD. You understand that such displays can be easily used in small devices. It is not a big thing. So the next thing that we can understand will be the three-dimensional viewing devices and input devices. Such kind of devices may include your stereoscopic or virtual reality system devices, and maybe other kind of virtual reality is also a way where we see three-dimensional objects. More than that, if we have to understand about input devices, we may be aware of some of the devices like keyboards and mouse, and there may be certain other devices. Nowadays you also understand touch screen is also input device. Other than that, joystick or trackball kind of things you would have seen. Digitizers are there. Apart from that, pen tablet is one of the input device. Image scanners can be there. Touch panels, you already understand. Touch screens are there, several dimensions, small or large, all are possible. So other than that, there is a light pen which can be done. Not only light and touch, one thing is voice can also be sometimes input. So voice recognition system, speech recognition system, such kind of things are also input kind of things. So this was the story of input devices. If we have to understand about output devices, you already understand that there are this monitor. Apart from this monitor, output devices can be printers. Such printers may be inkjet or laser and such a kind of other printers. Other thing that you should understand is softwares. Nowadays graphics softwares are available which help you to create such graphics. These softwares are built on the foundations of computer graphics that you are going to study now onwards. So basically from the next lecture we will try to understand what is the point, line, and how they can be displayed on this particular device, right? So these all the things are possible with graphics software. Means, okay, let me repeat this thing. Graphics software is something where these algorithms are already implemented and you can use them to draw certain kind of patterns. However, in this course you have to understand those algorithms and implement those algorithms, and I should say master those algorithms of computer graphics to understand very easily how these things are visible on the screen. Okay, so that in future when you will work with them, even if you are not using not writing the code for line drawing, but you understand how a line is being drawn, and if needed at certain time you can twist something in that to make something else. Okay, how these all the objects are drawn. I believe you will be able to understand these things in Blender. We have already started, so there you have to learn these things, and in Blender you are learning something about the 3D objects, how they are drawn. Okay, keeping these things aside, now these things like certain input devices, output devices, you should go through this book only, the computer graphics C version of Horn and Baker. In this book you will understand these things, and then in the next lectures we will try to include some more things about point and line, such kind of things. Okay, thank you.